Taking flight, a dream as old as imagination. The allure of flight has captivated humanity for centuries. From Icarus to Da Vinci's sketches, the desire to conquer the skies is deeply ingrained in our imagination. It encompasses a future where our cars take to the skies, transforming commutes into flights. Flying cars, once science fiction, are now edging closer to reality. Today, that seed is beginning to sprout. As we stand on the brink of this new era, it's time to explore the evolution and potential impact of these vehicles. From doodles to prototypes, a history of flying cars. The pursuit of building a flying car is nearly as old as the automobile itself. Early attempts, dating back to the early 20th century, were often imaginative but impractical. These pioneering contraptions, more akin to roadable aircraft, faced significant limitations in terms of safety, efficiency, and affordability. However, the quest for a viable flying car persisted. The post-World War II era saw a surge of interest, with several companies and inventors unveiling ambitious prototypes. These included the Curtiss autoplane and the Aero car, both of which attempted to bridge the gap between cars and airplanes. Despite these efforts, challenges remained. The complexities of combining the functionalities of a car and an aircraft, coupled with regulatory hurdles and safety concerns, hampered progress. The dream of a flying car, while still alive, seemed to remain perpetually out of reach. The science of soaring cars, eVTOL, and beyond. The 21st century has ushered in a new era for flying car development. Advancements in electric propulsion, battery technology, and lightweight materials have breathed new life into this long-held ambition. Today, the focus has shifted from clunky roadable aircraft to sleek, vertically taking off and landing vehicles. At the forefront of this revolution are electric vertical takeoff and landing aircraft. These vehicles utilize electric motors and distributed propulsion systems to achieve vertical liftoff and landing, eliminating the need for runways. Unlike traditional helicopters, eVTOLs are designed to be quieter, more efficient, and environmentally friendly. The transition from combustion engines to electric propulsion is key to making flying cars a viable mode of transportation. Electric motors offer several advantages, including higher energy efficiency, lower noise pollution, and zero tailpipe emissions, addressing some of the key challenges faced by earlier flying car concepts. And navigating the skies, the brains behind flying cars. Beyond the mechanics of flight, flying cars rely heavily on sophisticated software and artificial intelligence for safe and efficient navigation. These autonomous flight control systems are responsible for tasks such as obstacle avoidance, route planning, and communication with air traffic control. AI algorithms process vast amounts of data from sensors, cameras, and GPS systems to create a real-time understanding of the surrounding airspace. This allows flying cars to navigate complex urban environments, avoid collisions, and ensure a smooth and comfortable ride for passengers. The development of reliable and robust autonomous flight control systems is crucial for the widespread adoption of flying cars. These systems must be able to handle a wide range of scenarios, from unexpected weather changes to potential system malfunctions, ensuring the safety of both passengers and people on the ground. Challenges on the horizon: safety regulation and the urban jungle. Despite the significant progress, several challenges must be addressed before flying cars become a common sight in our skies. Safety remains paramount, requiring rigorous testing and certification processes to ensure these vehicles meet the highest standards of airworthiness. The development of a robust regulatory framework is equally crucial. Governments and aviation authorities worldwide are grappling with the complexities of integrating flying cars into existing airspace, establishing clear guidelines for operation, certification, and traffic management. Furthermore, the infrastructure of our cities needs to adapt to accommodate flying cars. This includes designated landing pads, charging stations, and air traffic control systems specifically designed for low-altitude urban air mobility. The integration of flying cars into our existing urban fabric poses significant logistical and infrastructural challenges. Untangling the traffic jam. How flying cars will reshape cities. The advent of flying cars holds the potential to revolutionize urban transportation and reshape our cities in profound ways. By taking to the skies, these vehicles can alleviate traffic congestion, reduce commute times, and provide faster and more efficient transportation options. Imagine bypassing gridlocked highways and soaring above the city, reaching your destination in a fraction of the time. Flying cars could transform daily commutes from stressful ordeals into quick and enjoyable journeys. This newfound efficiency could have a ripple effect, boosting productivity and improving quality of life. Moreover, flying cars could facilitate the development of new urban and suburban areas. With the constraints of traditional road-based transportation removed, cities could expand vertically, creating more livable and sustainable urban environments. This opens up exciting possibilities for urban planning and design. A breath of fresh air. The environmental impact of flying cars. The environmental impact of flying cars is a critical consideration. While electric propulsion offers a cleaner alternative to fossil fuels, the overall sustainability of flying cars depends on factors such as the source of electricity used to charge them and the efficiency of their manufacturing processes. If powered by renewable energy sources, such as solar or wind power, flying cars could significantly reduce carbon emissions compared to traditional gasoline-powered vehicles. This shift towards electric mobility aligns with global efforts to combat climate change and transition to a more sustainable transportation system. However, it's important to consider the environmental footprint of manufacturing and disposing of flying car batteries. Research and development in battery technology, recycling, and sustainable manufacturing practices are crucial to mitigate the potential environmental downsides. The economic feasibility of flying cars is another crucial aspect to consider. While early models are likely to be prohibitively expensive, mass production and technological advancements are expected to drive down costs over time. As with any emerging technology, early adoption will likely be limited to a niche market of affluent individuals and businesses. However, as production scales up and competition increases, flying cars are projected to become more affordable, potentially reaching price parity with high-end cars. The widespread adoption of flying cars will also create new economic opportunities. From manufacturing and maintenance to software development and air traffic control, a whole new ecosystem of industries and services will emerge to support this revolutionary mode of transportation. Imagine a future where your morning commute involves a quick pre-flight check on your smartphone followed by a smooth vertical takeoff from your rooftop landing pad. As you soar above the city, you can enjoy panoramic views and a stress-free journey to your destination. Flying cars have the potential to transform not only our daily commutes, but also our leisure activities and travel experiences. Weekend getaways could involve scenic flights to remote destinations, while business trips could become more efficient and enjoyable. The integration of flying cars into our lives will require adaptations in infrastructure, urban planning, and even our social norms. As we embrace this new era of aerial transportation, we must carefully consider its implications and work towards creating a future where flying cars enhance our lives without compromising safety or equity. As with any transformative technology, it's crucial to ensure that the benefits of flying cars are accessible to everyone, not just a privileged few. Addressing potential issues of equity and accessibility is paramount to prevent further social and economic disparities. Policymakers and urban planners must consider how to make flying car infrastructure accessible to all income levels and communities. This includes ensuring affordable access to landing pads, charging stations, and potentially even subsidized flying car ownership or ride-sharing programs. Moreover, regulations should be in place to prevent noise pollution and visual intrusion, particularly in densely populated areas. The goal is to integrate flying cars into our cities in a way that benefits everyone and minimizes potential negative externalities. The development and adoption of flying cars represent a paradigm shift in transportation, akin to the transition from horse-drawn carriages to automobiles. The rapid pace of technological advancement suggests that the future of transportation will indeed take flight. It's crucial to prioritize safety, sustainability, and equity as we integrate flying cars into our infrastructure. The journey towards flying cars may be challenging, but the potential rewards are immense. Flying cars hold the promise of transforming how we move, live, and experience the world.